Consider a scenario in which all screens turn black. Satellites were jammed. Sewn fiber optic wires. Attacks on military installations. The world's most powerful country might lose its ability to communicate in less than 5 minutes. What if, however, leadership could just take off? The next-generation nuclear command aircraft, a flying command fortress built to function in the event of pandemonium on the ground, is now in the testing phase of the U.S. Air Force. And you might be surprised at what this plane is capable of. Hold on, because this story is about more than just a plane, and every layer exposes something more. Number 7. The core mission survival of National Command Authority. One straightforward but crucial goal lies at the core of this program. Make sure that national leadership can continue to command military forces in the case of a catastrophic event, such as a nuclear war. Ground-based command centers can be the target of an actual crisis. Satellites used for communication could be interfered with. It is possible to cut off fiber optic networks. Cyber attacks have the potential to completely shut down secure lines or overload systems with false information. Decisions still need to be made in that situation, and they need to be made fast, precisely, and safely. This plane turns into a flying headquarters for the command. Strategic bombers in the air, ballistic missile submarines concealed underwater, intercontinental ballistic missiles in silos, and commanders worldwide are all connected to leadership. In a nuclear disaster, every second matters. Orders need to be verified. Verification of communications is necessary. Reactions must be thoughtful rather than impulsive. This aircraft guarantees the survival of command authority even under the most dire circumstances. Furthermore, stable deterrence is equivalent to survivable command in the theory of nuclear deterrence. Without it, escalation might spin out of control. Structure is left behind. Number 6. Replacing the aging Cold War platform. The E-4B Night Watch, also referred to as the Doomsday Plane, has been performing the function of airborne nuclear command for decades. During the Cold War, when nuclear war between superpowers was regarded as a daily possibility, the E-4B was constructed. It was designed with analog redundancy, fortified against electromagnetic pulse EMP effects, and able to stay in the air for long periods of time while refueling. However, as technology advances, so do the hazards. The strategic environment of today includes hypersonic missiles that can move at speeds that previous generations never had to defend against, anti-satellite weapons that can disable communications networks, and cyber warfare capabilities that can infiltrate antiquated systems. Older airplanes are likewise becoming more expensive to maintain. Finding replacement parts is more difficult. Systems created in the 1970s are not fit for fighting in the digital age. Modernization is essential, it is not a choice. The next generation aircraft is not simply a replacement. It is a development for a new age of warfare in which cyber attacks and electronic warfare are just as hazardous as direct assault. Number 5. The Boeing 747-8 transformation. The enormous Boeing 747-8, one of the most sophisticated commercial airframes ever built, serves as the basis for this aircraft. However, it changes drastically after being chosen for military conversion. Under the direction of Sierra Nevada Corporation, the aircraft is reconstructed as a hardened strategic platform after being stripped of its civilian interior components. It will have shielded electronics and wiring inside to resist EMP, extremely safe satellite communication systems, several redundant systems for communication, sophisticated consoles for battle management, secure locations for national leadership briefings, the ability to refuel in the air for increased endurance. Redundancy is built into every system. Another activates if the first one doesn't. Another frequency is activated if one signal is jammed. The aircraft is a multi-layered, resilient information ecosystem in the sky, not merely a communication point. Because even a few seconds of communication loss can have catastrophic effects in nuclear leadership. Number 4. Why the testing phase is so critical. The project moves from concept to capability when testing begins. This stage assesses flight performance in a variety of scenarios, such as stress testing systems in situations that mimic electronic warfare. Engineers evaluate the aircraft's ability to function in the event that satellites deteriorate. Under controlled circumstances, they test electromagnetic shielding. They confirm that even in the presence of interference, encrypted communication channels retain their integrity. In order to make sure they can carry out command procedures under duress, operational personnel rehearse crisis scenarios. Weaknesses are also revealed by testing. It highlights issues with legacy and new system integration. It compels hardware and software to work together under stressful conditions. And that's what matters. Systems used in nuclear deterrent must function perfectly not just on their finest day but also on their worst. This phase establishes whether the aircraft can actually function as a viable airborne operations center in a chaotic real-world scenario. Number 3. Strategic Context Nuclear Triad Modernization. The upgrade of the U.S. nuclear triad land, sea, and air-based deterrent systems includes this aircraft. The United States is updating ballistic missile submarines, replacing outdated intercontinental ballistic missile systems, and deploying next-generation strategic bombers, such as the B-21 Raider. Deterrence is strengthened in a different way by each component. However, if command authority is unable to interface with such systems, none of them are relevant. This aerial platform serves as the glue that holds the three parts together. It guarantees the safe transmission of orders. It guarantees synchronized replies. It guarantees that control is kept by the leadership. Survivability is stability in a strategic struggle with nuclear-armed nations. Number 2. The deterrence psychology behind it. Beyond hardware, this aircraft carries symbolic power. It signals to adversaries that even a surprise attack cannot decapitate leadership or paralyze response. In nuclear strategy, perception matters. If an opponent believes command systems are vulnerable, they may be tempted to exploit that vulnerability. But if they know leadership can survive and respond from the sky, calculations change. The aircraft strengthens second strike credibility, a cornerstone of deterrence theory. And credible deterrence reduces the likelihood of miscalculation. Ironically, preparing for the worst can help prevent it. Number 1. What happens next? Testing will continue for several years. Engineers will refine systems. Crews will train extensively. Secure communication networks will be integrated into broader defense architecture. Eventually, this aircraft will fully replace aging platforms and assume operational readiness. When it does, it won't make headlines every day. It won't fly in air shows. But during moments of geopolitical tension, it may quietly be airborne, ensuring continuity of command. Invisible stability often keeps visible peace intact. The next-generation nuclear command aircraft entering testing isn't just about hardware. It's about resilience. It's about survivability. It's about ensuring that in a world of evolving threats, leadership and communication endure. Because in the nuclear age, stability depends not just on strength but on control. And control begins with command. If you want deeper, detailed breakdowns of the systems shaping global power and strategic stability like this video, subscribe to the channel and stay informed, because understanding these systems helps you understand the world we live in.